Volume 1 of Quantum Mechanics, Foundations, The Quantum World by Srinivas Sridhar and Nick Bear Brown. Here is what is in it and how to work through it. 10 chapters in 3 movements. The first 3 are the world forcing the issue, classical physics failing, matter waves, and then the wave function and the Schrödinger equation. Chapters 4 through 6 take on free motion, confinement, and tunneling. Chapters 7 through 10 bring in operators, the oscillator, measurement, and the build. A chapter is about a week of a standard course, and this is a narrative, so read it in order. Every chapter has the same shape. You read the narrative and the derivations, which are written to be followed with a pencil in hand. Then a worked example on real numbers. Then the exercises and simulations to run and to build. The reader puts the volume in front of you in 3 frames, and that layout never changes as you move through the book. On the left, the contents, every chapter and every section. In the middle, the book itself. And on the right, a tutor that answers from the text of this volume. The left frame holds the whole volume, the front matter, the notation, the 10 chapters, and the back matter. Open a chapter and its sections appear underneath. Here is Chapter 6, on reflection, transmission, and tunneling. Choose a section and the reading frame goes straight to it. The middle frame is the book, the whole chapter with every equation typeset as it appears in print, and the figures sitting where they belong in the argument. This is the finite square well, and how far the wave function leaks past the classical turning points as the binding weakens. As you scroll, the contents frame keeps pace and marks the section you are actually reading. Previous and next chapters sit at the top, so you can also just read straight through. The simulations are what make this more than a textbook. 21 of them, embedded in the chapters that need them. Run them as they stand, and then build your own from the prompt each chapter carries. In Chapter 10, you assemble a working Schrödinger solver and check it against results you derived by hand. So every chapter ends the same way, a look ahead, the exercises, and the simulations. They run right here in the reading frame with nothing to install. This chapter alone carries 3 of them. Some you run to watch the physics move. Others you use to check a number you worked out by hand. This is the tunneling barrier from Chapter 6, and the controls are live. Raise the barrier, and the wave function decays harder inside it. Give the electron more energy, and far more of the wave survives to the other side. The right frame is a tutor for this volume. Ask it a question in plain language, the way you would ask in office hours. It reads the actual text of the book and returns the sections that answer you, ranked, with a snippet of each one. Click a source, and the reading frame opens right there. Everything it tells you can be traced back to a section you can go and read. Add your own key, and the tutor writes an answer as well, generated only from the sections it just found, with those sources still shown. It is a tutor bound to this book. Attempt the problem first, then ask. And the tutor does more than point you at the book. Ask about the free particle and it answers in full. It works through the mathematics step by step, with the equations set properly, the way a teaching assistant would at a whiteboard. Above the answer sit the sections it drew on, 10 of them here, and every one of them from this volume. Then it turns a question back on you and waits for your answer before going on. Which is the contract the book asks you to keep. Attempt everything yourself first, at least 20 minutes before any model sees it. Then use it as a colleague, not an oracle. Verify everything. The simulations are the exception. Let the model write the code, but you specify the physics and you check the result. So, read the 10 chapters in order, pencil in hand. Attempt first, then ask the tutor. Run the simulations, then build them, and finish at the capstone with a solver you wrote and verified yourself.